Hey, it's Nono, and I'm going to show you how to do some operations with TensorFlow in Python. So first thing we're going to do is make sure we can run Python code. So the easiest way that I know of, you can go to collab.research.google.com. So you can use Google Collab, which is a version of, I think it's a version of Jupyter Lab in size Google servers. So you can run a notebook in no time. And they even have support for not only CPU, but GPU and TPU for free. So if you go here, change the run type and click on GPU, you can, to get the most out of Collab about using a GPU unless you need one, learn more. Let's see what they say here. In order to be able to offer computational research for free, Collab maintains flexibility to adjust on the fly. We have heard for many users who want faster GPUs, longer running notebooks and memory, as well as usage limits that are higher and don't fluctuate as much. Introducing Collab Pro is the first step we're taking towards serving users who want to do more in Collab. So there seems to be plans for Google to scale this. So there is $10 a month recurring billing, and you can get access to that faster GPUs, longer time, more memory. What kinds of GPU are available in Collab Pro? K80s, P100s, T4s. Your notebook can stay connected up to 24 hours, and idle timeouts are relatively lenient. In the free version, they can run for at most 12 hours. And idle timeout is much stricter than in Collab Pro. So this seems to be a good alternative. We can use the free version, and that will let us run with whatever we want right now. So first thing that we can do, let's just make this a bit bigger. So we import TensorFlow, it's tf, execute that, and then we can just print tf version to see what version of TensorFlow we're gonna have available once our kernel initialized. You see now we're connected. This is going to be executed. We have 2.2 release candidate 3. So not even 2.1, we have 2.2. We can also run a command to see the version that we're running with Python. So this might be, I don't know, I would guess 3.6.9. And now we can start going. So we could do a simple operation with tensor. So easiest thing is like we can create a tensor from an array. So for instance, we have this data and we want to make a tensor. So that tensor that we got here, and I don't know why this is taking so long right now, but yeah, we have a tensor shape 3 integer 32 with that. We can perform simple operations within a tensor as if we were just performing math. So we can do tensor plus 1, for instance. And that, you see, just adds 1 to each member. If we log the tensor once again, we have the original. If we want to modify it, we will have to do this, or with better syntax, we can just do that. So now our tensor has changed to 2, 3, 4. If we want to preview that tensor in a more human readable way, even though we're losing information, we do tensor numpy. So you can just see the actual array with the contents of that tensor. And let's see, what else can we do? So we can perform multiplications. So let's say we do, let's see if we can work out with this. So multiply by 2 and then numpy. Yep. So yeah, so let's see, what if we do that? Yeah, so we just get the values there. Execute again. Yeah, so that's multiplying this by 2. You can see each component Of course, we can also do division, but that's still a bit boring. So let's go back to, let's say we multiply by 0.5, so we get back our integer. So maybe we divide. Nope, cannot do that. So so we cannot divide by 2. So we can do tensor equals tensor. Maybe that likes it a bit better. Oop. Okay, so let's go back. So now we've seen some operations. Let's go back and define, as we did before, our tensor as 1, 2, 3. So we can do, for example, run tf squeeze our tensor. That's not going to do anything because our tensor is already flattened. We can try tf.gather, and we tell we want from that tensor, we want element 0, right? What this is going to do, you see this index is getting this item, and if we do 0, 1, 2, we're going to get element 0, 1, and 2. We get the same tensor, but if we have values here, we could get, you see, for example, element 0, element 1, then element 0, then element 1, then element 2, 4 times, and we gather those elements in a new tensor, and we have a comma there. So you see, we have these numbers here, so we've gathered the values at these indices from this tensor that we're specifying here in a new tensor. So that's a really good way to just grab values from another tensor. So let's try to do, so this has shape, so it's 8, so let's make it shape 9. So for instance, to make it more apparent, let's just make this be this. So 1, 1, 1, 2, 2, 2. So we're gonna get, 0, 0, 0. So 1, 1, 1, 2, 2, 2, 3, 3, 3. So we can do now to convert this into an image, right? Something that would be represented, a tensor that represents a 3D image. We can do now, so let's say our tensor with gather, right? So it's gonna be this. And we now, we have this tensor, but we want it to be on the shape of 3 by 3 by 3, right? So this means that we have 3 items in the x, 3 items on the y, with 3 items each, right? So let's see how we can get that. We are looking for a tensor with shape that. So at any time you can say, okay, what's your shape, right? So we print, and just note that in any notebook, the last statement that you put is printed here. But if you have more code below, so let's say I define a variable, that's going to get printed. So if you want to print multiple things or things that are not the last line of a block in a Jupyter notebook, you have to print for sure. Okay, so we have a tensor that is shape 9, and what we want to do is use the function reshape tensor gather, and the shape that we want to try to do is, so let's specify here, and shape is going to be 3, 3, 3. Let's see what it says. Okay, input to reshape in a tensor with 9 values, but the requested shape has 27. So here, what we actually would be able to get is a tensor that, has this shape. Let's just mock it up here. So x, y, z 3 times, right? So the shape of this tensor is actually let's actually debug that. So we would get, right? So let's say that we have this, and then our tensor, or this is an array, has that value, and we can print our array. So that's our array, right? So we can actually do tf convert to tensor array and then ask for its shape. So wait, sorry. So we're gonna print that shape. Okay, so it's 3, 3. So what we can actually do in the tensor that we had here is that we can do reshape tensor.Gather, and now specify our shape is going to be 3, 3. You know, so now this tensor here that was a flat array has been reshaped into a 3 by 3 matrix. And what do we need to make it an image, right? So let's say we can just add another code block here and our tensor image. Maybe we can do gather, tensor gather. Well, we want to keep this reshape, right? So tensor gather reshaped. I'm naming these things too long, but you know, you can just name the tensor the same way all the way down and just have one variable be replacing its value. So we have this here, and we're gonna pick now. So you can see how if I do here in this tensor reshape gather, we have to run that block. So now if I print tensor gather reshaped, you see this value here, right? And the shape is 3, 3. Let's see if we can get, what can we get? So tf, yeah, so we have it here, tensor image. So we're gonna gather maybe element 0, right? So that gives us this. So let's see if we make this. Okay, we get it inside of another array. So the shape of this is 1, 1, 3. So this is actually an image with just one row, right? X equals 1, Y equals 3. You can see. So what we're gonna do is, well, actually it's 1, 1. So sorry. So the image would be width equals 1, height equals 1, right? There's 1, 1. There's only one element, 1 pixel, with 3 RGB colors, and those are RGB. That's 1, 1, 1. So in that pixel, we have RGB equals 1, 1, 1. Okay, so what we want to do is get an image that is not 1 pixel, but 9 pixels, so 3 by 3. How do we do that? So we can do, instead of doing this reshaping, what we can do is we can get 3 pixels with the first color, so 1, 1, 1, and now 3 pixels with the first color, and later, okay, so we have one array, second array, and then the third array is going to be the third color. We're going to see how that looks. Axis must be scalar. Okay, so let's just wrap this up on an array. All right, so now we have, I think we overdid it, but we are going to do a different thing. So we're going to take out this elements. How does that look? All right, so maybe we just needed to do this. Okay, let's just make it from scratch. So specify we want 3 rows. right? And we're gonna have 0, 1, and 2. Okay, so now we have an array for the first row, 1 pixel, an array. So this is 3 by 1, okay? And now we have 3, 1, and 2. So that's gonna give us a 3 by 3 matrix, right? You see? So we have 3 by 3. The 3 pixels on the top row are RGB 111, then RGB 222, then RGB 333. This is already an image. How do we visualize it? Let's just load matplot live pyplot. Oh, that was a really nice help. And now what we can do easily is plt image show, and we haven't really, oh yeah, tensor image, we have the variable there, and plt show. I'm sure I'm missing something, but let's see if this visualizes. All right, so we actually have it right. We can take out the axis if we want by running axis off, and we can do a bunch of things with pyplot. You can see there's nothing really there because the pixel colors that we're using are 111, 222, and 333. But we can go to something like Photoshop or the color picker here in Google, and I'm gonna get this color. So this is these 3 values. So let's just, before getting more colors from there, right? Yeah, so all right, so what we need to do is we need to define our colors here. So we're gonna have our first color, it's gonna be that one. Second, we'll change it later, and that one. So these are 3 colors. I'm just gonna get 2 more. So let's say we get blue, and then some yellow. All right, let's clean this up a bit. So we have our colors. So colors here, that works. So let's see, colors. I'm not sure if this is gonna work with this. That is an array, is not a tensor. We'll just try it. So from colors, I'm gonna do that gathering. You see, so we have a row with 3 pixels with red, 3 pixels with blue, 3 pixels with yellow. Now we render this. Whoa, nice. So we actually get that working. It's such a simple image. I think this is the flag of some country, I can remember. So, you know, the image, what makes a tensor an image is just its dimensions. So here we have a 3 by 3 by 3 matrix. So this means that we have 3 rows on the X, 3, so actually there would be 3 columns in the X, 3 rows on the Y, and then 3 values per pixel that represent the color for that pixel. This image could actually be easily turned into RGB if we just specify one value per image, right? So we have a 313. So that's actually not what I wanted. So that would be, I don't know if I can do it like this. Not really. Okay, so I'm not sure right now. Because we want it to be 3 by 3. Oh, okay. So actually what we need to do is make, because you know the shape of the array is being inferred by the data we're feeding into, right? And these colors are RGB colors, right? So these are RGB colors. What we would need to do is have grayscale colors, which, you know, the only difference is that we instead of 3 elements RGB, we just have one, so the brightness. So 0 would be black, 127 would be gray, and 255 would be white. And now these would be our element 0, element 1, and element 2 of our colors array. So we're going to say that our colors are going to be the grayscale colors. And when we do this gather operation, now we get a 3x3 matrix, but without any depth in the y, so in the third dimension. So if we try to plot this, you see what happens here. This is actually already a grayscale image. The only problem, or no problem, the good thing is this color palette is a color palette that Matplotlib adds when we have black and white color map. That that black and white color map gets represented with whatever color map we specify here. So for example, you know that Inferno has a gamut that is with red colors, and there are a ton of colors that you can use here. So CMap, Matplotlib, and I don't know, there are dozens, if not hundreds, of gamuts. Let's see. You see, so you can use any of these names here. So cool, for example, we use cool. You see, that's gonna use this color palette here. But you know, you might not want a color palette because we were saying that we had a black and white image. We didn't really have a colored image. So what can we do there? We can pre-process the image. So real image, let's say. There are a few things we can do. So we can, I think the easiest is if we do tf.keras pre-processing image, and then array to image function, and we pass our tensor image through there. So that's our real image, and then we show the real image. Oh, expected image to have rank 3, single image, got array with shape 3,3. Right, so what's happening here is that this image, even though Matplotlib plots it as an image, is not having the dimensions of a 3x3 image with a single channel. That would be 3, 3, 1. So what we're gonna try to do is reshape. So black and white image, let's call it, or image black and white. We're just gonna do a reshape of our tensor image, and we're gonna put it at the shape of, so 3, 3, 1. Let's see what happens. Okay, so that works. But let's see what output we're getting. You see, so that's 3, 3, 1. What happened is that those pixels got flattened on the x-axis to be independent components, but we still have the 0, 127, and 225. What happens here, I think, if we run this visualization with the tensor image, we're going to get the same that before, right? Matplotlib still understands it's a black and white image, but is rendering it with the color map that you choose. But we said that's not what we wanted. What we wanted is to render the actual black and white image. So we pre-process the image with Keras. So it transforms that black and white image into an actual image that can be rendered as it is. We run that, and okay, again, we don't get that, and this is because I'm not using image black and white. All right, let's see. Okay, so Keras helps us process images sometimes, but not always. So last resource I'm gonna try is tensor black and white is tf image grayscale to RGB, and we're gonna pass our image black and white, and this is what we are gonna try to render here. Okay, and now that we've done that all the way through, so this is what we actually have that is rendering the actual image, even though what we've done, and you can take a look at that here. So if we print the tensor black and white, you know, what it's actually done is make those colors a 3-component one. So we actually have a black and white image, but we're wasting information because we're using 2 more components that we need to per pixel. Whereas you can encode that image in a 3x3x1 tensor. So just to to depict that this was working properly, I'm just gonna make let's see if we can make a more complex example where we make a gradient, right? An image that has a gradient in colors. So let's say, I don't know, let's just make a loop here and make a tensor that has so x is going to be, let's just start with, well, 9x9. So 9x9 for e in range x. We have the gray colors are going to stay the same, and we're going to put this in a different block. So okay, we get that there. We just wanted this one. Okay, so we're getting that, and we would get here an image that is 3 by 3 because we're just using one component. We're just gonna do that, and that way we'll get a tensor that has 9x9. So that's a big image, well, a really small image in terms of the real images, but big for the amount of numbers we've been working with in this notebook. And I'm just gonna do it the old way. So we have an array of numbers that is empty, and we're gonna append each of those numbers there, and now we're gonna log our array. Right, so we have a big array of numbers. The first thing we're gonna do is get our array as tensor. So tf convert to tensor, and we put that array in, and we're not going to see it because we didn't print it. So we just want to print that here. All right, so we have that. How do we need to reshape it, right? So we just reshape our array as tensor as and then the shape is going to be what we said before, right? It's going to be 3x3x1, but in this case is x by y, so whatever size we need it. And now you see that we have that gradient where the tensor has split all those values that we're going to represent as colors across the gamut. So across the rows and columns of the pixels, right? From here, we can see we're going to go from black to some shade of dark gray, and we're going to try that, and we'll try to fix it later. But we already have a tensor that we don't really need to map with any colors or anything. So we can actually just delete all the stuff that we've done to gather our tensors and stuff, and we're just going to do the representation. So we're just going to show that array as tensor. Let's see if that works. Okay, invalid shape 81 for image data. So we are gonna try here to parse that as an image with Keras preprocessing. Expected image have a rank. Okay, this is the same problem we saw before. I thought with this we would be able to not have it, but we're gonna do a conversion of our image tensor, and grayscale image value 2-dimensional. Okay, let's actually inspect this element. So we have a 9x9x1, which should be a black and white image, but we're not saving it. Okay, so we didn't save it, so my bad. And we probably should have gone with doing this instead of plotting the numbers. So 9x9x1. So as I said before, I think this is something that Matplotlib should be able to render directly. Invalid shape for image data. Okay, so I'm gonna repeat the steps that I did before. Array to image, So we have our array tensor, and we have this here. So we have, okay, nice. So we got that gradient. You know, the part that we're doing here that in some ways cheating is that this map is being mapped on this on the color map that we select, or the default one, from 0 to 1, right? From the minimum color to the maximum color. You can see that here we can see the full spectrum of a color map. So here, so you can see the full spectrum of a color map with an operation like this. But this is also because, you know, Keras also helps us there, and matplotlib remaps the image. Let's try what we were going to do before. So if we try rendering that image as black and white, you see we can actually see the actual values of the colors. This is going from 0 to 80. And if we wanted to do our own remapping, so our own mapping of those colors, so they are going from 0 to 255 for whatever trivial size we choose to have on the image, what we're going to do is that, you know, this is the amount of pixels that we have. So let's say this is pixel amount, we put it here. And what we want to do is we want to see the total amount of pixels divided by 255, right? So our scaling factor is going to be the pixel amount divided by 255, right? So that way. So let's see if we do, for example, 255 divided 80, right? That's 3.18. So if we do here 3, oh, you cannot probably see that. So if we were to multiply that by 80, we'll get 255. That's the maximum number we want. So this is our scale. And what we're going to do is that we're going to append not the number, but the number scaled. And now we should see a full spectrum from black to gray. So pixel amount scale. Let's inspect the values that we're actually getting. There seems to be something failing here. All right, and those are not integers. Right, let's try to do one thing. So we got that the way I expected them to be converted to tensor with reshape, and then we have this tensor. This is actually what I was looking for. So we are going to try to do this, a cast 8, and let's inspect it again. Right, so that seems to be what I wanted to get to. Yeah, okay, so we've remapped manually, right? So what we did before was we had colors that didn't, and we can see we're not reaching 255. Maybe because we're starting at 0. Let's just try this. Okay, so now we're going from full black to full white. We have mapped it manually, but as I was mentioning before, if you don't do this remapping and you convert the image with Keras would actually map it from 0 to 1, and then matplotlib is going to represent it using the color map that you choose. And we can see that here, for instance, if I run with that cool color map, now we're getting the full spectrum. So now that we have this done, let's just play a little bit with it before we wrap up. And what I'm gonna do right now is I'm just gonna set an image that's gonna be, well, first really small, so 3x3. Let's see what we get. You get a 3x3 image in that spectrum of colors. And now we're gonna go to 256 by 256. Nice. So that's a perfect gradient. And maybe if you go, you can see, but I cannot see any difference with the pixels. So we've made a tensor. We've learned how to, this is a cool image. So we can put this here. Right. It's gonna be my wrap up background. So I hope this was useful. So this was an exercise to me to just remember some of the basic operations that you can use with TensorFlow to just manipulate arrays as tensors and change their shape and get array data and convert it into an image. So an image is just basically a 3 by not a 3x3, but like a x y by 3 or x y and the third dimension being 1, which represents an RGB image or a single channel image. You can have a 4-channel image as well if you have RGBA. So you can imagine that instead of having a 3-component color, we'll have a 4-component color with the A, so the 4th component is the alpha. So transparency that might go from 0 to 255 or from 0 to 1, depending on the mapping that you're doing. So yeah, this was a first video I've done talking about TensorFlow and how to manipulate tensors. If you enjoyed the video, leave some comments, maybe like the video, and also feel free to subscribe to get notifications when I go live or when I make new videos for the channel. Thank you so much. Bye.